Let's understand what is cross-validation in this video. Before understanding cross-validation, let's quickly recap on the data splits that we have seen previously. We split data into three sets. One is training, validation, and test. We split them because we use training dataset for learning. This is what we will use to train the model. And then the validation dataset is used to decide which model is a good model during the training process itself. Once the model is trained, once we know that this is the final model that we are going to publish, we want to share the performance of that model with the outside world, right? For that, we use the test dataset. So test dataset will never be used during the training process for any reasons. It will be used to publish the outcome of the final model. Let's also recap what hyperparameter means. Hyperparameter is basically rules about learning. This will set constraints for the learning. And this will not be learned from the data. This will be set upfront during the model training. In case of decision tree, depth of the tree is one example for hyperparameter. So if we specify the depth of the tree, then the learning process has to work within that constraint. If we set the depth to 3, then the learning process has to work with that constraint. It cannot grow its tree beyond 3 level deep. So that is the constraint it has to work with. And we normally set hyperparameter because having hyperparameter is going to benefit the learning in a positive way. But we will not know what is the right hyperparameter to use. That is where hyperparameter tuning comes into picture. So hyperparameter tuning is basically finding right hyperparameter for the task at hand in a systematic and evidence-based way. And the way we do that is by choosing candidate values. We will first choose candidate values. So in case of decision tree, we have picked 5 different candidate values here for depth. It could be combination of multiple values as well. So we may have multiple hyperparameters like depth of the tree and something else. In that case, we will have table of those combinations and those will be the candidates. But in this example, we have just one hyperparameter. That is why we have these singular values. Now for each of these candidates, we will train the model. We will train the model because we have 5 candidates here. We will get 5 trained model. But for each of those training, we'll use the same training dataset and same validation dataset. Okay, we'll use the same training split and same validation split for training each of these models. And the only difference will be the candidate hyperparameter values that we use. So once the model is trained, we will validate each of those models using the validation dataset. And that will give us the score for each of these models. And we will pick the best performing model. So that way, we know what hyperparameter has given us that best performing model, and that hyperparameter will be the finalized hyperparameter. Okay, so let's say for example 5 is the hyperparameter which gave us the best model. Then we will lock in on hyperparameter 5 for future work during the model training process. But there is a problem here. What if the selected model plus hyperparameter combination just happen to perform well on this particular set of training and validation dataset? We think that this is the best performing model among the other models that we have. But what if this is just a coincidence for this combination of training and validation dataset? So if that is the case, then our hyperparameter selection process is flawed, right? It is not the best hyperparameter. It just happened to be best for this combination of training and validation dataset. We want to make it more rigorous and robust. How do we do it? So that is where we'll use something called cross-validation. This is also referred to as k-fold cross-validation. So in cross-validation, what we will do is we'll take the dataset, the training and validation dataset. We'll still keep the testing dataset out of this. We will never use testing dataset during the model training process. We'll only use validation and training dataset. And we will split this into k folds or k equal portions. So if k is 3, then we will split them into 3 equal portions. Here we have split them into 3 equal portions. Now what we will do is we will rotate the responsibilities for each of these portions. If you see here in the example, for the first run, we are using S1 and S2 as a training dataset and S3 as a validation dataset. And in the second run, we are using S1 and S3 as a training dataset, but S2 as a validation dataset. And in the last one, we are using S1 as a validation dataset, and S2 and S3 are used as training dataset. So this way, we are rotating the dataset we are using for training and validation. We are not using the fixed set of dataset for training and validation. We are kind of rotating this for each of the run. And because we have threefold cross validation, we have 3 data splits, we have to do it 3 times. So now with this combinations, we train the model 3 times, so we will get 3 models. But all of these are done using the same hyperparameter. So we have taken a hyperparameter, and for that hyperparameter, we are doing the first model training using this combination. And then we are using second model training using this combination, and third model training using this combination. So each of them will give us one unique model. So we will have 3 models in total: model 1, model 2, and model 3. Now we use the validation data set of the relevant run and find the score for each of the model. And then those scores will be averaged. Let's say we have the scores like 0.2, 0.5, and 0.8. We will take the average of this, and that will be the final score for that particular hyperparameter. So this way, when we are evaluating whether a hyperparameter is a good hyperparameter or not, we are not relying on a fixed set of training and validation data set. We are rotating the data set like this, so we can be much more confident that whatever score we got for this particular hyperparameters model is indeed a valid score. Here we have used k as 3, but it can be any number of value. So k basically means how many splits that we are going to have. In this case, we have used 3, but it could be 5, 8, or anything that you like. So this is going to increase the number of training that we need to do for each of the model. If k is 100, then you need to train 100 models to get the average score. Okay, so that is what cross-validation or k-fold cross-validation is. But now let's quickly understand what is grid search. Grid search is basically automating the cross-validation for different hyperparameters. Like we have seen previously, for one of our hyperparameter, we train the model 3 times because we are doing threefold cross-validation, and we will be getting the average score. But the whole process of this training is to find out the best hyperparameter, right? We want to find which hyperparameter performs best, which means we need to do the same process, the same training process, the same threefold cross-validation for this hyperparameter has to be repeated for other hyperparameters as well, right? So we want to do that for hyperparameter 2, find the average score, and we want to do the same for hyperparameter 3 and find its average value if we have 3 different hyperparameters, right? So the whole process of doing the cross validation for all different hyperparameters and finding the best hyperparameter is called grid search. Now let's look at when we want to do cross validation. So cross validation will be useful when you have small or medium data set. Okay, so if you have small or medium set, then using cross validation will give us the confidence that the score we are getting from each model is a good score. And it will be useful when hyperparameter choice matters. Okay, some of the hyperparameters may not be that significant, but in your training process, you are working with a particular architecture or algorithm, and in that hyperparameter is very important. In that case, you need to use cross validation to make sure you are picking correct hyperparameter. And let's also see when we shouldn't or it is not recommended to use cross validation. Cross validation is not recommended when the data set is huge, because when the data set is huge, we can assume that the training data set that we have is enough to give the generalized performance metrics for the model that we are training. And also, if the data set is huge, it is going to take a large amount of time and effort to train the model. So in that case also, we don't want to do cross validation. And another reason for not doing cross validation is when training is expensive. So you are developing a really large model with a large amount of data set, with a large amount of compute effort, then doing cross validation is going to be very expensive in terms of computation as well as cost and time. So for that reason also, it is not recommended to use cross-validation. So if you are developing a small model where hyperparameter matters, use cross-validation. Whereas if you are using large data set to develop a large model, then cross-validation is not recommended. Okay. Now let's look at the full model training process with the understanding that we have gained so far. So the first step is we need to get the training and validation data set. Once we have them, we will decide whether we want to do cross-validation or not. If you want to do cross-validation, we will do cross-validation and we find the hyperparameter. So the cross-validation is performed to select the hyperparameter. Once the hyperparameter is selected, we will train the model again using both training and validation dataset. So during cross-validation, we will only train the model using training dataset, and validation dataset will be used to find the performance of that model. But after the hyperparameter is selected, we'll combine training and validation dataset, and that dataset will be used to train the model again using the selected hyperparameter. Okay. Then we collect the performance of that model using the test dataset. So once the model is finalized, we know this is the final model that we are going to publish. We want to share the performance of that model to the outside world, right? So for that, we use the test dataset. So this is the only place where we will use the test dataset. So test dataset will not influence the model training process. So once the performance is evaluated on the final model, that will be shared with the outside world or published to the people who care about that within your organization. Then that model will be deployed. So that is the model we will deploy, and that model will be used for production use. Okay, so this is the whole training process when it comes to model training. So that is all I wanted to share in this video. I hope this is useful. Thank you.